Good morning and welcome to part 3 of my walkthrough video for this practice SAC. So, gas conversion company has two types of gas tank available. One is the additional, which goes into the boot and allows the car to run on both gas and petrol. And the other one is the replacement, where they take the petrol fuel tank out completely and replace it so that the car runs on gas only. Now, the conversion company wants to know how many tanks of each they should make or buy or bring in so that they can make the most amount of money. So the important thing to realize is that there's a word in there that tells you the type of question that we're probably dealing with here. And that question is this word here, the maximize question. So he's trying to maximize something, which means that we're probably going to be dealing with a feasible region and an objective function. Now, if we keep going, we see here we've got constraints. These are the constraints. We've got a graph here. The graph talks about feasible region and corner points. Groovy. And then there'll be an objective function question down below. So the first question A says, if additional tanks are X and replacement tanks are Y, write down the 4 constraint equations associated with this problem. Now, the reason why I've not read over this bit first is because I need to know what sort of language the questions are expecting. So the questions down here say additionals are X and replacements are Y. So when I think about that, I'm going to use X's and Y's to represent what's going on here. So his business can only install a maximum of 120 tanks a month. So what this tells me is that if you add up the total number of X's and Y's that he makes, that cannot be more than 120. It can be 120, but it must be less than or equal to 120. So that I would say is my first really important constraint. He knows just generally based on the demand that he's got, he has minimum requirements. So he has to have a certain number of tanks in stock ready to go. And he knows that he has a minimum requirement of 40 additional tanks a month and 30 replacement tanks each month. So that means if additionals are X, then that means X must always be greater than or equal to 40, because we're talking about a minimum of 40, at least 40. And then because replacements are Y, then we're talking about Y must also be less than or must be greater than or equal to 30. Now, the other equation that we've got here is a different type of equation, but it still influences the numbers of each that he can make. The question says it takes 3 hours to install an additional and 5 hours to install a replacement. Makes sense. You've got to take the odd one out first. The company has a maximum of 450 hours available for installation every month. So every X costs 3 hours. So we'll say 3X. And every replacement costs 5. The company has a maximum of 450 hours. So because it's a maximum, we want to use that symbol, and that's your 450. So those are your 4 constraint equations to describe the situation. Now, remember, if you are doing this on your CAS, you can't just type these inequalities into sheet 1 above. It doesn't work, because remember that y1 colon is like y equals. So to do anything involving what we've got going on here, we need to convert them. Luckily, so that we can draw them, our CAS can rearrange them for us. So what we're going to do is we're going to go to the CAS, and we are going to go to main. And what we're going to do is we are going to use equate, we're going to do solve. Now, we'll need our keyboard for this, and we'll need to go to Math 3, because Math 3 is where all of our inequality symbols are. The solve button is also in there as well. So we're going to go x plus y. Remember, you can get x and y from using var or ABC. It must be less than 120. Now, because our CAS is expecting it in y equals form, we want to put it in y equals. So we want to go comma y, and we get that inequality. So we're going to keep that. We'll use it in a minute. Now, the x is greater than 40 and y is greater than 30. We don't need to do anything with those. We'll leave them be. The next one we have to worry about is the 3x plus 5y is less than 450. So again, we're going to go solve. 3x plus 5y is less than or equal to 450. And again, we're solving for y as well. So you'll have to take note of which way the inequalities are pointing. In most cases, they're going to be pointing towards the equation. However, there are times when that occasionally doesn't matter, or is occasionally the other way around. So you have to pay attention very carefully. So now that we've got those two, what we need to do is we need to put all of our inequalities into our CAS. So to help us out with that, we can drag. So if we press this down arrow here and we bring up y1, y2, it splits the screen for us and puts us into the equation at the top and then the graph enter down below. Now, ignoring the inequality for now, we're going to grab that line and we're going to drag it down. And then we're going to do the same for the next one here. Now, what you'll notice is when I drag them down, they change to equals, not semicolons or colons. So what we need to do is we need to go in and we need to click on that and we need to change it so that it is pointing the right way. So we want to make sure this and this are pointing the right way. And we'll do the same for this other one here. And then you want to make sure you tick them. Now what we need to do is we need to put in our minimums. So x's and y minimums. So y3 colon blah. So what we want to do is when we've got it like this, we want to press this down arrow here and we want to pick the right inequality symbol. So we'll pick this one here for y. Now it won't change anything yet, but the moment you type in your 30, it comes in. And then for the x, we want to do the same thing. Now what you'll notice is that the x4, it's now x4, x5, x6. So if you were going to enter any extra inequalities after that, you would need to change it back to y. But luckily for what we're doing here, we don't need to do any more than that. So now we've got 4 equations, or 4 inequalities. And when we graph them, well, of course there's going to be nothing there because we aren't looking in the right area. I mean, you look at the numbers that we're working with, 120, 450, 40s, and 30s. Of course, there's going to be nothing there. So again, like we did with the previous questions, we want to set up our graph window so it looks like the graph window that is on the paper that we need to work with. So in this case here, we've got 160 along the bottom and 160 along the top. So let's set up our CAS graph the same way. So we'll go -10, and we'll go all the way to 160, and we'll have a scale of 10. Again, we want to match them, so it's as easy as possible. Again, -10, 160, and scale of 10. And we want to hit OK. And we get this lovely graph here. Now, your graph may possibly look a little bit different if your CAS is set up in a different manner. So my CAS is set up in inequality plot intersection. Yours might say union. And if it says union, it looks like that. And in that case, you're then trying to find the most shaded area. But that's a little bit hard. So that's why we go graph format and we change it from union to intersection. And then it gets rid of everything we don't really care about. And we only have the shaded region. So now what we need to do is we need to start placing some lines on our graph. Now, there are 2 very easy ones for us to do because they are the x is 40, x is greater than 40, and y is greater than 30. So a line there to make it nice and thick to make it obvious. And then I'm going to get another one. And we're going to put it over 40. Now remember, these lines are obviously important. And we will go for we want to make sure our line is appropriately sized. Need to redraw that actually, because I think it tried to draw me a curved line, which I don't want. I want a straight line. That's better. All right, so I've got my two inequalities here now. I'm just obviously just going to label them. Y is greater than 30 and X is greater than or equal to 40. So obviously, if these were just our only two inequalities, then we would be shading this whole area here. But we're obviously not doing that. We want a different one. So using our CAS, what we're going to do is we're going to find some intercepts. So on the CAS, we're going to go analysis, G-solve, and we're going to find y-intercept. So that's the blue line there. That's negative x plus 120. So we've got 120 there. So I'm going to put a dot there. And then I'm going to go analysis, G-solve root on that one, which is just an x-intercept, also at 120. And now I'm going to draw a line. That passes through those 2 points. And I'll make it nice and thick for you guys. So that's the first one. Now we need to go back to our CAS, analysis, G-solve, y-intercept, but we're going to do it on the red line instead. And that's at 90. And then we'll go analysis, G-solve, root, again on the red line, and it'll take us all the way down to 150. And then from here, we'll again, one more time, we're going to draw a line that connects those two dots that we just made. And so now you can see that we've got our lines there that match what we've got on our CAS, and then we have our shaded area, which is just in here. Now, our question says, clearly indicate the equation of each line that is drawn. So this one here is x plus y is less than 120. And then the purple line is 3x plus 5y is less than 450. So we've clearly labeled all our lines. The only other thing we need to do is indicate that this area here is our feasible region. And then there's one more thing, and it's this one here, the corner points. So as you're going through the question, sort of mentally tick off the things that you've done and put on your graph. The corner points associated with the feasible region. So our feasible region, I'm going to change color pens for this just to make it a little bit easier. We'll go with the brighter blue for this. So the corner points associated with the feasible region are this one here, wherever these two lines intersect here, this one down here, and that one there. Those are the 4 corner points that we now need to find. So in this case, this one here is pretty easy because it's where the 2 perfectly straight lines intersect. So that's 40, 30. This next one up here, you would have to take x equals 40 and put it into the equation and then find out what y is. And that happens to be 66. 40, 66. This one down here, we can use our CAS to help us with. So what we're going to do is we're going to go analysis gsolve intersection. And it's going to ask us to pick the first line we want to find the intersect with. And then the second one, which is the red one. So we can see those 2 are flashing. And we get this lovely point here, 75, 45. 75, 45. And then one more, we now need to find where the blue and the green line up. Analysis gsolve intersection. Blue is our first one. Green is our other one. So they're now both hot pink. And that one's going to come out at 90, 30. So the only one that I haven't shown you how to do is to find this other one here. Now your CAS, because it is an X inequality, it doesn't do solver. So if you try and go analysis intersection, it only lets you pick y1, y2, or y3. It doesn't let you pick x4. So that's why you have to do a little bit of extra thinking for yourself. So what we do is we go back to our main. Now we actually already have this inequality here. And what we can do is replace that x with the x value that we know we're looking for. That's 40. And then it comes out and gives us a 66, which is what I said before. So that one quick way that you can easily do that to work around that restriction. So we now have our corner points. We've labeled them. Beautiful. We can move on with our lives. So the next one down, we're now looking at profit and objective functions. Nice and easy because we already know plenty about the situation. Remember, additional tanks are X. So X and replacement tanks are Y. So the objective function, we'll call it P because we want the profit. And that's going to be 200 times X plus 300 times Y. Now, using the corner points of the feasible region, which is above, we want to calculate how many tanks should be installed each month to maximize our profit. So we need to create a table of values, which a bit hard to do with the amount of space that we've got here, but it's relatively easy to do on our CAS. So what we're going to do is go to our CAS, and I'm just going to start going. We're going to go over to spreadsheet, and I'm going to type in my corner points. So I've got 40 and 56. I've got 40 and 30. I've got 75, 45, and I've got 90 and 30. So in C, what I'm going to do is I've got my objective. I'm going to put in here my objective function. That's going to be 200 times A2 plus 300 times B2 well, maybe it doesn't need that sum in there. I'm thinking of Microsoft Excel. There we go. And then we want to copy that and we want to paste that down the ones below. And from there, we can see which one has the highest thing going on there, which is this one here. So that table would go into your SAC. You would draw it up the way you've always drawn it up. So what is the maximum profit? Well, using a CAS, it's 28,500. So if all of a sudden the company gets a different supplier and the profit is the same on both, 350, what is the new objective function? Well, it's going to be 350 times X plus 350 times Y. Profit, dollar profit, is going to equal that. What is the profit the company can now make, and how many tanks should they make to make this a reality? So we've already got our spreadsheet set up. We can just go back and we can change that 200 to a 350. And that's the 350. And then we can go edit, copy, edit, paste, 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 and we've now got the objective function put into our spreadsheet, and it's already done for us. So what is the maximum profit they can now make? Well, it's now $42,000. If they make, remember, worded question, worded answer. If they make 75 additions and 45 replacements, or 90 and 30. And then that's it. It's done. Question answered. Thank you for watching.